looking at web app security essentials. And when we talk about web app security essentials, it's basically trying to make us understand the basics, one of the fundamental things you need to know when we are looking at web app security. And we are looking at web app security essential because it's part of the curriculum that the fundamental that every cybersecurity person is expected to know. For example, if you are talking about CompTIA Security Plus, for instance, there's an aspect where the curriculum talks about web app security, which everybody is supposed to as a fundamental knowledge in cybersecurity. Web app security is essential because if most of the applications, most of the things that we'll be securing web apps, everything, a large percentage of what we do happens on the internet, and when you talk about internet, that is where you encounter web applications. So we're just going to look at the common web app, protocol or web protocol on which most web applications are built. So if you are going to access most web applications, you are going to have to go through these protocols I'm talking about. And this is HTTP. HTTP, if you remember, when we are talking about network security, HTTP is one of the protocols that we talk about. And HTTP protocol is responsible. HTTP protocol is responsible for internet web browsing, www. So we are going to look at HTTP methods, the cookies, and the threads. How most of us here we understand what HTTP and HTTPS. At least fundamentally, I believe we know what it is. So I will just run through this part. The meaning is hypertext transfer protocol, which is the foundation of web communication. And this determine, and when we talk about protocols, they are like rules. So these things determines or guides how requests and responses are being structured. And it works on port 80. So when we talk about request and response, it means if you access the web, your computer will send a request that I want to see this web page, and then the server will respond with the details of what you have requested for. So HTTP is the foundation of web communication. Then we have HTTPS. HTTPS basically is just a secured version of HTTP, and it uses TLS, to encrypt communication. I think it was in the last class we talked about encryption. If you remember, we talked about encryption. We did some demo practicals on encryption. So this is a type of encryption that makes HTTP secure. So when we talk about encryption here, we are looking at we are protecting confidentiality. So encryption means people cannot see it, and this TLS, transport layer security, is a method, is a way of encryption, carrying out the encryption on the data that is being communicated via the HTTP. So, and the encrypted ports on which HTTP communicate is 443. So for the unencrypted is port 80, for the encrypted is port 443. So if you are scanning a web server, you are conducting a test, you are running a scan, you want to scan for vulnerability, and you are scanning a port, you scan port 443, or you need to submit your information on those websites. It has to be encrypted with HTTPS, so that the details, the information you are typing into that website will not be transmitted in plain text. If it is not encrypted, it will be transmitted in plain text, and that means whatever we are communicating will be seen. If anybody should intercept it, it can be seen. But if it's encrypted, it will not be seen. So it prevents eavesdropping and data tampering. And the difference, looking at the major difference between HTTP and HTTPS, number one thing is the security. HTTP is not encrypted. HTTPS is encrypted using the TLS. But the port also is different. Port 80, port 443 for HTTPS. So I just want to mention that you need to be familiar with these ports, because most of the time when you are troubleshooting, when you see it means that communications is being done in plain text. So you need to get familiar with such things. Then the data integrity too. HTTP is vulnerable to modification. Meanwhile, HTTPS remains secure because, of course, it's being encrypted, so you can't see to modify the data. Then authentication too. HTTP is not authenticated. HTTPS uses SSL and TLS certificate. So this is another form of a difference. So if you look at most of the time when you go to a website, they will tell you check the certificate, check if there's a key icon by the left. It used to be a golden TLS. So sometimes we're still going to be looking at the structure of how SSL and TLS work, where we call it public key infrastructure. So these are major differences between the HTTP and the HTTPS. So please, if you have any question as we go along, you can just ask. The uniform resource locator for that resource that you are looking for. So what we're saying is that if I have a website now, I host my website on my own server or on a server that I chose. That server where I'm hosting it has there will be a locator, something for locate that resource on that server. That's what we call the URL. So is that URL that I will give you, or is that URL that I will give you, or I give anybody that wants to access what I'm visit a website, for instance, you might start with www.example.com. But when you click on example.com, it will take you to what we call the index page, which is like the home page. So, but once you move from that page to other resources on that same website, the full site, and in this URL that you see on the screen, we'll do a breakdown of what it means. So if you see the URL like this, is what we have about 5 components here, or 6 components. The scheme, which is the HTTPS, which talks about the protocol that is being used, so which is the first part of it. Then we have the host or the domain or the IP address, because usually it's the domain we give, so that domain is what we can easily remember. But like we talked about earlier, domain will be resolved. The DNS server will resolve the domain, that you give into an IP address. So sometimes you can just put the IP address directly, especially when you're in a networking environment and you are communicating directly with hosts. Sometimes you may not use domain name. So then we have the port 443. This is optional. Default port for HTTPS is 443. Default port for HTTP. Why I said it's optional is because once you type in your web browser HTTP, in fact, once you type the domain name into your web browser and the web browser, the DNS server resolved the domain name, and it found that the website or the resource you are trying to locate is being set up on an HTTP protocol, automatically the browser will connect via a port 80. So you may not need to specify, but if you specify, you are just helping the application to go there directly. So port 443 here, like we see in the URL, is for HTTPS. Then we have the path, path to resource, which is the path to the specific, location of the resource. So if you are viewing a web page, for instance, that is what you will see, in the resource. If you are viewing maybe a file, it will be the path to the, file. Then query parameters, these are key values sent in the request. So this query parameter will determine what happens when the website where the application opens or locates the resource that you are searching for. So these query parameters could include things like maybe the ID or a particular section or something that is unique, that gives the specificity to what you are looking for. So that is the query parameters. For example, if you are going to a site where you need to log in, with the username and ID. So it's after the query parameter, it's under the query parameter that you see this name and login stuff that you see. Now, the fragment, here, this is a section used for internal web page. So this one is not shown in what we are seeing. here. So hash, which is a hash section. So if you are doing a particular page or a particular section of the page, that is what will be displayed there. Now let's look at example of what a request looks like. So this is structure of an HTTP request. So basically why we're looking at these things is this is the communication that goes on whenever you click open a web page or web browser, when you type a web address, whether it be just a simple web page or a web application. This is the request that goes on. And for you that will be working, for anybody that will be working, for example, in a SOC, maybe you set up a SIM, maybe you set up a Splunk, a SIM solution, or like we checked the other day, an event monitoring solution. This information, this is what will be seen in the background. So if you check your logs, these are the kind of information you will see in the log. And from this log, from a log like this, you can interpret, So example here is this HTTP request. So when you send an HTTP request, this is the way it looks like. You see get one index, get index.html HTTP1. Then you specify the host, user agent, and accept. Let's see the details. So the first part of it is the method. And when we talk about method, this is define the type of request. Here we are saying get because it's a request, there are different type of request method. There could be get, there could be pull, there are other requests that are like push. Push will be like you are sending thing. Get, the way they respond different. So pull is usually like you are, when you say you pull something, you are taking something. Get here is like you are requesting something will be served to you. Pull is like you're drawing. But let's not go into that one for now. I'm trying to touch on this one because you will see all these things in your logs. That's where this lecture is ending. It's talking about logs because that's what concerns you as a cybersecurity person. When you look at the logs, you need to be able to interpret what the log is saying. So if you see things inside the logs, you see a get is talking about a get method. It means that the query was sent to request for something. It defines the request type. Then we have the path, the index.html. That is what we are requesting for. So if you open your web browser and you send a message, you want to view view a web page. This is the message that you send, index.html. Then the protocol, HTTP 1.1 is not secure. It's the plain text HTTP. So if it's like a version, if it's like 2 point something or 3 point something, that would be the other version, the secured version. Then we have the headers. These are additional metadata that you see, the host, the user agent, and the accept. So when you talk about the host here, the host, of course, is the domain name that we are referring to. Then we're talking about the domain name we're referring to is the host. We're also looking at what they call it, the web server. The user agent, sorry, the user agent is Mozilla 5.0. User agent is talking about the browser. So anytime you are looking at your logs and you see user agent, anything that follows the user agent is talking about the browser, which is the application you are using to access the resource. So then the accept, that is the what you are sending. Accept, this is the way in which you be sent. Is the text version and the HTML. That is what is accepting there. Okay, so sorry. So we're looking at request, response. Here is we are talking about response, HTTP response. So if you remember the first part here, we're talking about the request. That is, you are sending a request. For the request here you are sending is to get an information. Of course, after request, you will get a response. When you get the request, the response is also has its own unique structure too. Excuse me. Okay, so when you have a request, you have a response. So an example of how the response look like is what you can see on the screen. So we have the HTTP 1.1 200. Okay, so we are still going to look at what 200 means, what those they are called status codes. HTTP 1.1 200. Okay, date, you're going to provide the date, which is the date the page was actually used to respond. So if you look at the details of what is inside the request and response, so we are looking at the status line, which is HTTP version, status code, and status message. So the status message is okay, the status code is 200, then the version looks like. So we have HTTP. This response is HTTP 1.1 200. Status code is 200, which says message is okay. The server responding here is not an Apache because I screenshot this from another excuse me. Whatever the response is, that is what you see here. So we have of course, this is the website, that you see. So that's how the response is when you request and you respond in HTTPS. So is partially updating. You know what a patch means? It's not basically like you're upgrading the software. That's what we call patch. Then we have the head. If you see head, it means that request is to retrieve only headers. It's not going to come with the content of the web page. So if you send a head request, you get back excuse me, you get back only the headers. So it happens a lot, when you are trying to query or try to check whether a resource or whether the code is working. We just want to check whether the web server is active or is working. If you call for a head alone, it will bring you the headers and you can look at the headers and see the details of what the content is like. Then options is when you are retrieve it allowed HTTP method for a result. So options is like it will tell you the kind of HTTP method that are available on that when you send a kind of code with when you issue a command with options. If you are familiar with Linux that we were doing last week, if you put -H, it will give you options, to give you the things that you can do. So options here is basically going to tell you all the methods that are available when you use it as a code. But the importance of what we are doing here, because we need to relate it to cybersecurity. We're talking about web app security. So if you are checking a log, if you run let's say even Wireshark, you do a traffic capture, maybe there have been some complaints or you are just checking randomly whether to see what's going on within the network that you are securing, your organization, you're working as a cybersecurity person, and you did a traffic capture and you are looking at the logs or you are looking at the data of the traffic and um, you are seeing things like get, post. It will give you an idea of what is going on behind the scenes. So if you see an IP address that is sending a request with a get method, you know that IP is definitely trying to retrieve something, from a particular resource. If you see in the log, you are seeing post, it means that IP address or whatever is behind that IP address is trying to push something to server. Maybe it has a virus or it has a corrupted file or a script that is then trying to send. So it depends. So your judgment will depend on what the application you are dealing with. If you are application that is supposed to just retrieve, you know, and you are seeing post on such application, of course, it's a signal. You can know that something is going on. Maybe the application has been hacked or something has interfered. Then when you see something like put, that means the IP address is trying to, or this, whoever is sending that message is trying to update something on the server. So this could be pointers to the next action you will take, and it will depend on the kind of or where you are seeing the method that is going on. So later we are still going to look at in our practice in the print while putting the practicals, we're going to try and look for this information in what we call in the traffic that will monitor. So I mentioned earlier on the status codes. So when you see the status code, I'm sure a lot of us, while browsing, sometimes you will see error 404, error 50 this, error, you see 22, you see 30 something. So these are status code that tells us what is going on with the HTTP when we send. So if you see anything that starts with 1, it's talking about information. So if you get a response or you get a query and it sees 10, 101, 10 something, they are basically information. So they are not to raise alarm particularly. It's just to it's just to give you an hint of what is going on. Then we have when you have 202XX. So anything in the range of 20 something or 200, 201, 202 or 200 is a success. Usually it's still 200 you will see. Like we saw in the examples, examples we look at earlier, you can see the screen, you see HTTP 1.120 okay. It shows that it was a success. It means if you send a query and it gives you 200 return, it means it successfully got to the destination. Then we have 300. So 300 usually comes. So maybe we'll see something like this when we are doing the demo. That HTTP 1.1, if you are trying to open a website, and maybe before the website was previously HTTP, and the person has now upgraded the website to HTTP, version 2, HTTPS. So if you send a query and the resource you are looking for is no longer where it used to be, you will get a status code of 300, which will tell you this web page has been moved, or this web resource has been moved, and you give you 300. So when you see code 3 something, is a redirection. Then 4 is client error response. So if you see error 4 something, error 403, it means, are we following? Are we following? Are we following me?
Yes, we are. I'm following you.
Okay, thank you.
Yes,
So,
sir.
okay, so we have the samples of these status codes here. So we have 200, we have 301, 301 means that they move permanently direction. 400 means bad request. Remember, 400 is a client server error. That means if you say it's invalid request syntax, that means you are not typing it properly. 401 is unauthorized. That means you don't have the authorization to view what you are trying to view. So you need to provide authentication. In this case, maybe you check whether you need to log in. Then 403 means forbidden access denied. So if you see some website that they will tell you that they are not supposed to, check from Nigeria or from Africa, maybe from particular side of the world, it could be from US. Maybe you are in US, or maybe you are in Ukraine, for instance, and you are trying to open something in Russia, or you are in US, you are trying to open something in maybe China or whatever, and then those websites are not meant for people in the region where you are. So it will tell you access denied, forbidden, so subject. Or sometimes maybe they've checked your login details, they checked your authorization, and they feel that you are not, they don't want you to access it. So that's when access is denied. Then and it could be it could when you are getting it, it could be an attack too. So all these things, all these error ones can be an attack. For example, if you check a website and it's telling you move permanently, and the owner of the website is telling you that he didn't move it, that means someone has, you can give you an idea that okay, when you are dealing with somebody, maybe a man in the video, somebody has moved, you know, has replaced the domain or the IP address with another one, and then is redirecting to a different place. So these are pointers. 404 means not found. The source is not available. It means what you are looking for is no longer there. Then we have 500, which is the internal server. So 500, like internal server error, means server failure, error 500. Yeah, so we have, these are the common, these are the most common error message you're going to encounter when you are, troubleshooting or browsing or trying to open a particular thing. So that's for status code. Now we're looking at cookies. So you can be wondering what is an HTTP cookie. HTTP cookies and their roles in web security. Excuse me. Sorry, let me confirm something. Okay. So when you're talking about HTTP cookies, these are pieces of data stored on the user's browser for session management and tracking and personalization. So I'm sure you will have had a cookies a lot. I'm sure most anybody that uses website, you will have seen the information because part of the regulators, regulators of data regulators, they are always part of the regulation or requirement is that if you are using a cookie on the website, you are supposed to notify the person browsing. That's why a lot of times you see a pop-up when you go to the website, they will tell you that this they are using cookie, this session is being tracked with a cookie. They will tell you, and then you need to agree. If you don't agree, sometimes if you don't agree, you will not be able to browse the website. Sometimes the cookies are just meant for them to get something for them. If you say you are not agreeing in agreement, you will still be able to browse the website. But you are supposed, no matter what, you're supposed to be notified of the cookie. So basically, these are data about session. So what he's saying is that if you log into a website now, what makes it happen that if you're on a website and you close your website, or close the tab, or maybe you move from the tab to another one, you will not be logged. You are not logged out. The fact that you are not logged out, you don't have to open the website afresh. These are the things that cookie does. It helps to manage session. It also helps in tracking. I'm sure you are always familiar with this. When you go to a site to check something and suddenly you are seeing adverts. Maybe you went on Facebook and you click something about Jumia, and then in your email, everywhere you go, you are seeing Jumia adverts. So these are cookies. And it's also used for personalization too, just for you to make sure that the good use of it is that to filter away things that you don't need. So we have different types of cookies. We have the session cookies. So when if it's a session cookie, usually expire immediately you close the browser. So, but if you don't close the browser, it will still be active. So once you close the browser, it's for security. These are things you need to take note of in cybersecurity. So if you are you're configuring your website setting or everything, you should set the cookies so that they expire. If the web resource or the site is something that is very sensitive to privacy, if you notice most of these bank web application, or the portals, if you are doing something on the bank page and you log out, you change, you minimize, even you just minimize the browser or you close the browser or you move to another page to do something else, it will log you out. So those are they use them to prevent, because if the cookies are active and they have not expired, if an hacker takes hold of the cookie, even if the person is not on your system, the person can launch the cookie and use it to hack, you know, to get into the your you know your portal to check what you are doing, to access the resource you are accessing as though they are the one, as if it was you. So those are session cookies. They always expire when the browser is closed. Then we have the persistent cookies. So they remain stored until expiration or until you delete it. So this is common in web pages that are not, when normal web pages that you view, maybe your Facebook page or a news page that you can leave it for a long time on your browser for sometimes for months. That page will remain there. Anytime you launch your web browser, it will come up. So those are persistent cookies. Then secure cookies. These are cookies sent only over HTTPS. Then HTTP only cookies. So this one prevent access via JavaScript to mitigate access. So HTTP only cookies is saying that it will not be able to run a script. It is just basically for text, HTML. You'll not be able to run a script. And most of all these hackers, the scripts they run on your web application. So when you are browsing, a script may be running behind. So if it's HTTP only cookies, these cookies are set in such a way that anybody that tries to run a JavaScript, or run any script, to carry out any functionality while on that session or using that cookie, it will not work. So this one always is used to mitigate XSS. XSS is cross-site scripting, attack. So security risk in cookies. Like I said, session hijacking. Attacker can steal a cookies a session and impersonate you. Cross-site scripting. So these are malicious scripts that access cookie data. So this one they can use it to be popping up, sending fake messages. You can when you see some pop-ups that you are not requesting for. So somebody else will go into your website, and they will be receiving messages they are not supposed to receive. Those are XSS. Then we have cross-site request for Gino, which is an advanced version of the cross-site scripting. These are malicious scripts that have been running on your web page that exploit authentication. So request cross-site request forgery is talking about it will be sending some requests, be carrying out authentication, without the owner's permission or without the victim's permission. So these are scripts that run, and these are all possible by cookies. So let me see what's the next thing. Okay, good. So let me. Do you have any question before we try and do some demo?
Everything is clear for me. I don't have.
Okay. Okay, Charles, do you?
Good, sir.
Okay. Okay, fine. So let's look at some demo now. Let's start with cookies. I need to stop this. Okay, so for cookies, what we need to do basically is to go to a web and see. Okay, I'm going to use it. Let me use you can be doing this also on your system, Microsoft Edge. Let me use Microsoft Edge. So you can see my screen now.
No,
Right.
okay, it's coming up.
Is it up now?
Yes, I can see us.
Okay, fine. So I think for most web page is if you click on the dot dot dot, it will open up, pop up the file or pop up or right click on the browser. You see these options, and then for this for Microsoft Edge is more tools you're going to see. So under more tools, you see developer tools. So what we are looking for is I want to check, just want to see the cookies. Yeah. So for every, like we said, for every session that you are using, there are things going on. What's going on? It's not open. Oh, it's slowing down. What's happening now? Is there anything? Oh, I don't know why this is not showing. Okay, showing now. Okay, so I'm trying to show the. So for Microsoft Edge, it's a little bit confusing. Let me see the elements. Okay, can you see now? If you see the screen, here we will have the network tab. Let me look for the network tab. Oh, okay. Oh, I think it's a bit complicated for Microsoft Edge. Let me use where's network tab? Okay. Let me use a Chrome. For the cookies, we are looking at the cookies. So you can see all the resources that the browser has requested. It will show on this under this network tab, and then you will see the details. You can see the detail of the request and response. If there's any cookie used, it will see. You can see the status of all the status. Let me try and do something. You can see as I'm opening, it's showing, it's giving me information. Let me check a website I can go. You can see the details. Yeah. If you can see the screen, you see all the information going on. You can see, for example, the status is telling me 200. These are the names. These are the resources, like the URL. These are the communications going on behind the scene. So this is where you see every information you want. Let me see. Can see the message sent. So sorry. So basically, under here is where you see all the information you are looking for. You can see the details, the request that was sent. The request method is get. The status code is this is the address. This is the IP address. This is the file policy. And you can see the response. This response header here. Accept. Catch. This is where. So if you are, of course, eventually you decide if you're into web applications and you need to be checking the configuration to check whether the application is secure, or if you are looking for what they call this thing, maybe you are participating in capture the flag, or you're looking for a bug, or you are looking for what is going on. You are just investigating. All these places are for you to to see what is going on behind the scene. You can see authority, google.com, as of course provider, method is get, the path. You can see the scheme, HTTPS. You remember we'll talk about accept. These are the kind of encoding language. Cookie, see the cookie here. So this cookie is the cookie for this. This is what will ensure what is going on here. Then you can see the downlink. So basically here, I've participated in some capture the flag, or maybe some tests actually, where some codes, some things are embedded or are hidden on the web page, and they will tell you to look for it. So for example, now I remember there was a test I did some sometimes early last year, whereby it was for a company in Ireland also. So they tell you need to just look for they hit some flags on the website, so, and they tell you to look for it. So one of the things you basically do is just if you just view either you do come through this way, or sometimes you just view if you view the page source, which will show you the HTML of the web page, you can see all the things that are hidden there. If it's not there, if it's hidden properly, if you check the network like this, you can see a breakdown of all the communications that are going on when you are on that website. You can track information based on what is going on, and from here you can easily you know, flag whatever is going on. You can see here it says user agent, Mozilla, you know. So basically this is the header, this is the payload. Payload is basically is the source that's been sent. Then preview, of course, you can see the details. This is the response from the server. So this response is basically it will contain, in addition to the header, it will contain all the things you see on the website. All the things you see on the website. Visitor, timing, cookies, all the cookies, name, different, all the cookies for every item or resource on it. So basically, this is how you check for the cookies on a site, and check the status code and everything too. Any question? I'm sure. Are you familiar with this? Oh,
Oh, I'm familiar with it, but I don't really understand how it works before.
okay. So do you have a better understanding now?
Yes, but I still have to go through the class again.
Okay, of course you have to go to class, and you understand it more when you are doing it yourself. If you are able to, if you are doing this yourself, you understand it more. Let me check something. So you can see basically this. If you are looking at it, this is explaining. This part is explaining what is going on here behind the scene. And this is where sometimes if you go to a website, and those websites where they have maybe they have embedded some script that are doing funny things, you will see it here. You will see all the script that is running. You can look here for you can easily see anything that is funny going on here. Although it may take a while, for you to understand it, but that's basically at the fundamental level. This is what is going on. This one is, of course, is experience, work experience, how to come in when you begin to deal with web applications from time to time, and you come here because this is a field. This is a field in cybersecurity in its own. Web application. Some people, that's all they do. So you can't compare. If you are not, if it is different from network security. This is web application security. These are web application guys. Okay, Charles, any question? I think you say you are familiar with it, Abi.
Hello? Hello, sir.
Hello.
Yeah, I'm familiar with it, but they didn't really go through it like this. I'm still trying to pick up.
Oh, sorry. It's Derek that I even wanted to mention because I didn't hear his voice. You have spoken already.
See, I hear me.
I can hear you now. You say
Yeah.
you are familiar with that stuff too, Abi?
Oh no, I just know how to get there, but I don't know how to read the logs. I don't know how to do what in cybersecurity will call find the flag or something. Don't know how to use it to detect, but I know how to navigate there.
Okay. Oh, and I've closed it. But you saw what I was trying to do now, Abby? You saw the page,
Yeah.
right?
Yeah.
Okay. And so basically, once you are familiar with those error codes, that is what makes it like this page now. Once you are familiar with the error codes, you will see, you know what you are looking for. Like here now, this is where I was basically. You know, this for as you move on this website,
Developer options.
yeah, developer options under network.
Mm.
So network is what we'll be dealing with basically. Yeah. Anyway, we're talking about cookies. Basically, that's why we came here. Do you understand?
Okay.
So for these are the resources that you see, and we are seeing different things are happening under the resources. For each of the resources, you can see. So if you look inside this section, this is where you look for to find what you are familiar with. You know, if you are looking for something, you will know what you are looking for anyway. But if you are just checking generally, you know, maybe I'm just looking for an IP address. You can even filter here if you have an IP address in mind. For most cases, you are looking for something that you don't know. You are just looking for something that is, that is unusual. You can check here. Each of these resources, if you check it, you see the details here. Here, you see the details here. So you can say this request method, this is posting something. And remember, when we talk about post, it means it's trying to update something. You know, so it's what I said in summary is that this is a fundamental, review of it. We are not going into the detail because it will take a separate class, not maybe not even one class for us to break down all these sections. You see, talking about payload response, we even have, all these sections, each of them stand for different things. For those guys into web application security, they are the ones that really deals with all this. Immediately they come here, they will know where to look for what they are looking for. But basically, we were just talking about cookies. What brought us here is cookies. Wanted to see cookie. So you want to check the cookie that is going on or that is being used by a particular page. So if you click here, you look for the resource, you click on it, and then you go on there, you see the cookies that is being used. Part in asset. Let's see. You can see this is the cookie for here. So you may need to come back here on your own and fiddle with it. You can't spoil anything here. The worst you can do is to close the tab and open it afresh. You understand? So don't be afraid to try it out. So you can see pointing it. If you check the chat box here where we are in this meeting room, just go to wireshark.org.
Where will we install the Wireshark?
So you can install it on a normal
OS.
OS. Then you also, for you to install it in your Kali, you need to launch your VM, launch the Kali, and then there's a browser. There's usually Mozilla, the Firefox browser inside the Kali too. So when you launch your Kali lineup, you can open the browser and download Wireshark for Linux there, so that you can use. Although I think it comes with Kali itself. If you launch your VM, I think Wireshark is one of the tools that come with it. Launch your VM first and check.
Okay.
Launch your VM first and check. Let me even launch mine and see. But for the okay, so this is the Wireshark. Charles, I think you should launch your own. So we can be working together. Can you see my screen? The Wireshark is coming up.
There's Wireshark in it.
Only to be okay. Right. So if you can see my screen, this is the Wireshark coming up. So it's these are when you launch it, these are it opens, it comes on, and what is showing on the screen, Wireshark basically is used to monitor traffic. So what it does is that it's monitoring every communication going on between your computer and or any port. If you can use the monitor port, so there are different ports on your computer. I mean interface, not just port, interface on your computer. So we are looking at your USB interface, your Wi-Fi or your LAN network, any kind of interface that your system. So you can monitor the traffic going in and out of it. So for this case, now if you look at the screen, you can see my own here, it can capture traffic on my Wi-Fi, the VMware connections, I can capture the local area, but the one that is working, I mean, is Wi-Fi I'm using to browse now. So everything I'm doing on Wi-Fi is what I can monitor. So if I select it, all I need to do is to select it now and double click on it. So if you can see my screen, it's showing all the communication that is going through my Wi-Fi port, all the communication. So, and the good thing about it is that I can just click on capture. So normally, once you launch it, it will start capturing. So, but if I want to stop capture, I can stop capturing packets. So all the ones that it has captured during that period while I was allowing it to be recorded, I cannot be checking it one by one. So now, following what we are talking about, HTTP, we are looking at HTTP because a lot of communication is going through the Wi-Fi. Some of them are not HTTP. So if you look here now, let me see. If you look in my screen, you can see packets. The total number of packets that it has captured. It's 916. So I can filter for HTTP. If I filter for HTTP, you can see out of all the 8,000 plus, it's only 4 of them that are HTTP. And I can look at HTTP. You can see here now, this one is talking about HTTP. Okay. So another way you can use this now. HTTP means that communication is not secure. So now, if I'm investigating what kind of communication is my system sending out that is not secure. So if I filter for HTTP, I know that all these things are not secure. So I can look at this IP address and say, what's going on? Who is communicating? Which IP address is this? I can double click on it. You see, I can see the detail of the IP address. Yeah, okay. If you here you can see the version, the identification. Let me check. Of course, it's port 80 destination port. I'm trying to see what is communicating. This is an act segment. Okay. HTTP accept server content length request. So I'm trying to look at the message it's sending. So it's sending message on Microsoft. You can see something is sending something it has to do with and information on Microsoft. I can look at it here in details. Sometimes I can dig deeper, but I don't want to dig deeper. We will have a different class on Wireshark where we look at how to use this Wireshark properly. But basically, what this Wireshark is telling me is that when I filter for HTTP, I can see all the communication going on HTTP here. I can see the length, the head. This one I can follow. Sometimes I can follow. Let me see. You can see the details here. So if you remember what we talk about here, HTTP, this is message, this is the content type, this is server, which is communicating all the messages. Is a get, so is a request, is requesting for something. I can see other details here. Accept, user is saying Microsoft. Of course, I'm sure this has to do with the Microsoft applications on this system, because I'm actually using a Windows. So definitely for you that you are using a Mac, I'm sure the information you will see, most of the communication you will be seeing here will be detailed, will be related to Apple, or Mac information. But if you look here, what I'm saying is this I can filter in Wireshark here to see what is going on. Let me check for HTTPS. Do you notice that when I type HTTPS, it shows red? That means it's not seeing HTTPS. So that HTTPS too that we see that I was talking about is the same thing as HTTP, but it's a different version. So HTTP 1.1 is HTTP without secured. So HTTP 2 and 3 will be the secured one. Let's see. Nothing 3. I think it's 3. Let's see. So it means, okay, it's trying to load. Okay, you can see. So it can't filter for, it's not showing. Okay, it's trying to load me. Okay, Charles is going on and out. His network is, looks like his network is misbehaving. Okay. So you can see all the HTTP. So there is no HTTPS connection here. They didn't capture any HTTPS connection. Maybe let me recapture again. What I would do is that,
that's the way they do.
eh?
I'm not talking to you. Sorry. Thought I was muted.
Okay. Oh. So I just opened the web page there. I want to see if it captured that web page. Like I even if you are following me, are you trying it on your side too? Hello?
No, I'm not trying it on my side. I'm just watching what you're doing.
Okay.
But
Oh,
I have my track open on my VM.
on your VM. Is it connected to the internet? Is it connected to the network? Let's see. I need to relaunch it. Okay. I want to capture fresh. But if you are following me, are you trying it on your side too? Hello?
No, I'm not trying it on my side. I'm just watching what you're doing.
Okay.
But
Oh,
I have my track open on my VM.
on your VM. Like I even I need to relaunch it. Let's see. I need to relaunch it. Okay. I want to okay, this my try to open some website so that
I said I was trying to do. I don't know. Was I muted? Like I was talking and I was muted. Did you hear?
I click on the Wi-Fi interface and it starts to capture. After a few seconds, you can just stop the capture and view what is going on. So you can see my screen. If you see my screen now, you see all the things that it has captured. All the messages and the communication has been going on. So you can now apply a filter. It was working fine. It was working fine earlier on. I don't know what's wrong with the app is misbehaving. My app is misbehaving again. It was working fine earlier on. So you can filter. This is Wireshark. Basically, you can look at everything, every information. So if you click on any of these web links, you see the details under here. And under the details, you can check out. You see internet program. You can check out what message is, the details of the message going on. Yeah, you can see. This might have to just start to hang. I don't know what's wrong with it. Okay. I'm looking for something that explains it better. The command is so that you can understand what I'm saying. Run that command in the terminal. And let's see the response to get it. Oh, you have closed the. I'm no longer sharing your screen. Okay, no problem.
I'm sharing now.
I mean, you have closed the Kali. That's what I wanted to say.
I did not close it.
Let's stop there. What I will do is I will take a snapshot. I will I will troubleshoot. I will fix my Kali and then run and then do a screenshot and paste.
Oh, okay. Okay.
So I won't waste too much time so that I can then possibly I'll try and check if I can what I can do, how you can talking about CompTIA Security Plus, for instance. You know, there's an aspect where the curriculum talks about web app security, which everybody is supposed to as a fundamental knowledge in cybersecurity. You know, web app security is essential because if most of the applications, most of the things that we'll be securing are web apps, everything, a large percentage of happens on the internet. When you talk about internet, that is where you encounter